So what's the first thing that I need to do if I'm solving this problem with elimination? So we decide which variable we want to eliminate, okay? X is easy. Z would be easy as well, right? Now y is not hard, it's just that X and Z are easier, right? Okay, so which one do you want to choose? X, okay? So if we're going to solve this by elimination, what do you want me to do first? Combine the first and second, okay? So the first is x plus y minus 2z equals 5. Negative x plus 2y plus z equals 2. So that's 0. Three y minus z equals 7. Is everybody in agreement with that? Okay, now what? Why middle in the bottom? Oh, it's already negative, so I'm just multiplying this by 2, right? Okay. Some of you yesterday did this. You did negative 2x plus 4y plus 2z equals 2. I mean, I know it's 4, but some people didn't multiply the 2 all the way through. They only multiplied it on one side. Okay? So make sure you remember to do that, okay? What am I combining that with? Bottom. And then I combine those two together? What does that give me? Well, that's really nice, isn't it? Why is it really nice? If I combine these two equations exactly as they are right now, my z's cancel. They go to 0, don't they? Okay. What if we decided right now to simplify by eliminating the y's? Could we do that? Yes. What would I have to multiply this by? And what would I have to multiply this by? Negative 3? Right? Okay, so we would have same signs opposite, or same numbers opposite signs. Well, I don't have to do that because my z's go away easily. I just want you to realize that there's multiple ways to get it done, right? So if I say 3y minus z equals 7 and 7y plus z equals 13, what does that give me? 10y equals 20. Good. Y equals 2. Now what? Like here? Back here? Now that would be a poor idea, right? So in one of these two, okay? Which one? Your first comment is, it doesn't matter, right? And then your second comment is, but I would choose because, okay? You would choose this one because it's smaller, okay? I would maybe choose this one because of positive z. Because 7 and 13 aren't really that much bigger, okay? But you said the first one, so I'm going to choose the first one and just show you that it really doesn't matter. So 6 minus z equals 7. So negative z equals 1. So z equals negative 1. Yes? And now what? Donde. That means where in Spanish. One of the first equations, one of these over here. And why would you choose the first one? Which variable are we going to be solving for? X. This x is by itself, isn't it? Okay. This one wouldn't be hard. I had to divide everything by a negative. And this wouldn't be hard because I just divide by a 2. That's pretty easy. Okay. But you said the first one, so I'll choose the first one. X plus 2 equals 5. Is it okay that I did that in my head? Okay. So x plus 4 equals 5. So x equals 1. And what do we think our answer is? 1, 2, negative 1. It occurred to me yesterday afternoon that there is something you can do in the calculator on this that I did not show you. So may I show you that now? Okay. So I want to do a new document. Guys, all this does is help you check it. It just gives you a way to check it. Okay? The first thing I'm going to show you just gives you a way to check it. So I'm going to say x is 1, y is 2, and z is -1. So I'm just going to tell the calculator I want to take 1 and control vars. So I'm choosing store. I'm going to store 1 as x. So 1 stored as x. Enter. You okay? And then 2 stored as y. Entered. And then -1 stored as z. Enter. So there's 2 ways that you can do this. I want to show you both ways. Okay, at this point, going back to the original, let me zoom in just a little bit so you can see the screen a little bit better. Whoa. Can I make it where I can see the screen and the problem? That would be nice. Okay, so I might do x plus y minus 2z and hit enter, and it tells me that is 5. Well, the equation says it's 5, so that's good as well, right? But I also could, let me show you with the second equation the other way. I could say -x plus 2y plus z equals 2. And when I hit enter that time, it says true. So it doesn't matter which way you do it. Okay, you can either put just the left-hand side and see if it equals the number that the equation tells you, or you can put the whole equation in and it'll either tell you true or false. If it's false, it's not working, but if it's true, it's fine. Does that make sense? So 2x plus 3y minus z equals 9. True. Now for some of you, that might be a little quicker to check, but for some of you who are pretty good at arithmetic, it's probably not any faster than just plugging the numbers back into the equations, but I wanted to make sure to have shown you that. Okay? Now, after spending 4 days on substitution and elimination and graphing with 2 variables, and after spending a day on substitution with 3 variables and 2 days on elimination with 3 variables, and then a quiz, I guess just 1 day with elimination, right? And then a quiz, today is typically the day that you are upset at me. And I accept that. Okay? Because today is the day that I show you how to do this in the calculator. Don't throw stuff at me, Connor, unless it's money. You hear me? Okay? Let me walk you through the steps. You ready? Here's the steps that we're going to take to go through this. Okay? I'm in a calculator document right now. I just started a minute ago, so it's not that crowded. So I'm just going to go ahead and go on the page that I'm on. Is everybody okay with that? So the first thing I need to type in is menu. And we're going to choose number 7, which is matrix. Now, this doesn't have anything to do with the movie. Okay? I'm not going to come to school with a long black jacket on with my hair slicked back. That would be terrifying. Okay? Before we even go on any further, I need you to understand what a matrix is. Okay? For our purposes, and in most every purpose, a matrix is a rectangular array of numbers. It's just a way to arrange numbers. Does everybody understand that? Okay? We're just arranging a set of numbers in a specific way. Okay? What we're going to choose is reduced row echelon form. Okay? Reduced row echelon form. Now, on this menu page, it says actually reduced row echelon form, but when I choose it, all it says on the calculator is RREF. That stands for reduced row echelon. I know that was just a joke. I'm sorry. Okay, reduced row echelon form, RREF. Everybody understand that? So right now I have RREF and some open parentheses. Okay, I need to go back to menu and back to matrix. And this time I need to create my matrix. Again, not the movie. Okay? And I need to create, and like I said just a minute ago, I need to create a matrix. Okay? Now, we're talking about this system of equations right here. Okay? Now, before we can go on, I need to actually write down my matrix. Okay? We're using this system that for number one, we already know what the answer is. That will help us know when we get to the answer. You okay with that? So here's the system that we're using. I need to create my matrix, and this is part of the work that you have to show on these kind of problems. Since we're doing it all in calculator, there is certain work that I'm going to ask you to show. Okay? Matrix. Yeah. Okay? I want to take this system of equations right now and just write down the coefficients. What is a coefficient? It's the number in front of the variable. That's exactly right. Okay? So what's the coefficient here? 1, 1, -2, and 5. Now, please understand that this thing that I'm showing you only works if these equations are in standard form. X, Y, Z equals the constant. This only works if this is in the right order, in the correct form. Does everybody understand that? Okay, if it's not in the correct form, you have to put it in the correct form before you can even start. Okay? What about right here? -1, 2, and 2. Everybody okay with that? And then the last one? 2, 3, -1, and 9. So the question comes up because we've had systems like this before to solve that the system looked like that, right? One of the equations only had 2 variables. Well, what would I do in this situation for this x? What would I have to put in? I have to put in a 0. There has to be a placeholder for every variable. Otherwise, it's not a 3×4, which is what we'll talk about in a second. There has to be something represented for every variable. And if there's not a variable, why wouldn't we not put in a 1? Well, it's not there, so it's a 0. If there's a 1, it is there, isn't it? Okay? So this is what my matrix looks like right there. Okay? That's my coefficient matrix. This is the first, besides writing on the problem, this is the first step that you need to write down. Does everybody understand that? Now, we're going to go back to our calculator, and we're going to look at it for a second. It's asking us right now how many rows and how many columns we have. Well, how many rows do I have? 3. I would recommend strongly that you use the tab button to go from one to the other. Because if you start using the up and down arrow, it's going to actually change the value of the number in there, and that's not what you want. So remember to use the tab button. Once you have 3 rows and 4 columns, hit OK. Now the good part about this is if you put in the wrong number of rows and columns, it's not going to look right. Does this matrix right here look like the one I need to put in? It does, so we've done it correctly. Okay? Is everybody with me? If not, please ask somebody at your table, and if not, you know I'll help you. Okay so far? Now we need to put the numbers into our matrix. Well, we have our coefficient matrix. We're just putting it right here. Now, another hint, use the tab button in between each number, because once I get to the end of the row, see how I'm at the end of the first row? If I hit tab, it just takes me to the second row. I'm not having to do up and down arrows all the time. I'm just hitting tab. Can it be done with up and down arrows? Absolutely. Okay? Now, at this point right here, I'm going to put in some personal commentary right here and say before I do anything right here, I'm going to look back at my problem. 1, 1, -2, 5, -1, 2, 1, 2, 2, 3, -1, 9. And just check to make sure what I put in is actually what I wrote down. Does that make sense? It took maybe 3 seconds, but it's going to save me a whole lot of time later on if I accidentally put something in wrong. Now, then I hit enter. Now, this is the second part of the work that I have to show. 1, 0, 0, 1, 0, 1, 0, 2, 0, 0, 1, -1. Now, we know the answer from the previous problem because it's still right here. Do you notice that it's right there? 1, 2, -1. Do you notice it's that last column? Because here's the deal, guys. If I transferred this matrix right here back into an equation matrix, or an equation, a list of equations, wouldn't this say 1x plus 0y plus 0z equals 1? And isn't 0y and 0z nothing? And doesn't x equal 1? And 0x plus y plus 0z equal 2. So y equals 2. And 0x plus 0y plus 1z equals negative 1. So z equals negative 1. Oh my geez. There's the answer. I still have to write it. How do I have to write it? As a point. Because it's still an ordered triple. It's still a place in space where three planes or three things are meeting at one point. Correctly? Why did I say correctly? I meant to say correct. Sorry, I didn't mean to say an adverb. Adverb? L-Y? Yes. Adverb, right? We'll go with adverb. Okay. I said correctly instead of correct. I didn't mean to say an adverb. Isn't L-Y an adverb? Okay. Yes? Okay. I'd meant to just say correct. I'm sorry. So, just so we're clear, we still have some more stuff to talk about, but I just need to be clear for you. When you're doing homework problems or problems on a quiz or problems on a test, you have the problem written down, you have your coefficient matrix written down, you have your answer matrix written down, and you have your answer. If you want full credit, you'll have all four of those things. Does everybody understand? Okay. Now, is this always true? Probably not, right? That would be way too easy. You might do a problem that looks like this, like that, okay? And you write your coefficient matrix, and it looks like that. And then you get your answer matrix out of the calculator, and it looks like this. Do you notice right here? This is the important part. Yeah, the answer is the important part, but this is super important also. This is only the answer if x is this, y is this, and z is this. If you have a diagonal of ones right here. Do you understand that? Do you see how this problem does not have a diagonal of ones? When it doesn't have a diagonal of ones, go look at the last row. The last row is going to tell you what the answer is. If I converted this back, it would be 0 plus 0 plus 0 equals 3, right? So 0 equals 3. Does 0 equal 3? Will 0 ever equal 3? Then what's my answer? No solution. Does everybody understand that? Or we could do this problem right here, and our coefficient matrix looks like this, and our answer matrix looks like this. So do I have a diagonal of ones? No. Then look at the last row. What does that translate into? 0 equals 0. Guys, does 0 equal 0? Then what's the answer? Infinitely many solutions. So when you have a diagonal of ones, your answer is sitting right there, x, y, and z, which we write as a point, right? An ordered triple. When you don't have a diagonal of ones, like these two don't, look at your last row. Your last row is going to tell you what the answer is. If you translate it back into an equation, it says 0 equals 3. That is not true and will never be true, so that is no solution. If you translate this row back into an equation, it says 0 equals 0. 0 does equal 0, so that is infinitely many solutions. Do you understand? Do you have any questions about this? How long is this going to take compared to this? And so that's why you're typically mad at me. Okay? Same rule applies for everybody that applied for Connor. If you're going to throw stuff at me, it needs to be money. Okay? I would prefer you not throw a bag of nickels at me, but at least it's money. Okay. Oh, Connor. Chocolate is different. That's a whole different story. Do you have any questions about any of this? Okay, I did write the order. I guess I wrote that order. That's the order you need to go in. I don't know if you saw that earlier, but that's there of how to put stuff into the calculator to solve it with a matrix. Okay? Before we go, I want you to make sure you can answer these questions. Okay? What is a matrix? It's a rectangular array of numbers. Okay? It's an arrangement of numbers. All right? Why are we using it to solve a system of equations? It's faster. Okay? Do you still have to know how to do elimination? Yes. Okay? There will be questions on quizzes and tests that say solve by elimination. And if all you do is write down the answer, you will not get full credit because you're not following the directions. You understand? Absolutely. But you could also plug the values back into the equation to check as well. Okay? Does everybody understand? Okay. Any questions on this? Somebody ask me a question to make sure you understand. Can I go through the steps? I sure can. So on the calculator. Oh, the first step I didn't write down, so make sure you have it. Turn the calculator on. That's an important step. Okay? Menu. Matrix, then start with reduced row echelon form. If you forget to do that and just go to create, you can always go back and put that in at the beginning, but I just like to put it in first. Okay, so reduced row echelon form, and then back to menu, back to matrix, and this time we're going to create a matrix. The ones that we're doing right now, because they have 3 variables, there'll be 3 rows using the tab button and 4 columns. So it looks like that.
Trevor's trying steps, and whenever he presses menu on the home screen, it doesn't do anything. He needs an extra step.
Oh no. Okay, we'll talk in a minute. Everybody understand? Okay. Any questions on this? Was that good? Okay.